Hello to everyone. This is Mohammed Toyeb, Assistant Professor of Mathematics, Jamal Mohammed College, Trichy. So, in this lecture, I will focus on what is a linear Diophantine equation and what are the solutions of the linear Diophantine equation. So, before that, we will discuss a puzzle, Mahavira's puzzle. Uh, 23 travelers entered the outskirts of a lush and beautiful forest. They found 63 equal heaps of bananas and 7 single fruits, and then they divided them equally. Uh, can you find the number of fruits in each heap? That is, number of bananas in each heap. Also, with this, can you say that how many fruits divided by the travelers equally? For answering these questions, we will discuss what is linear Diophantine equation. So before that, we formulate the puzzle into a mathematical equation. For that, let us consider x be the number of bananas in each heap and y be the number of bananas received by each traveler. So the corresponding Mahavira's puzzle is 63 times of x plus 7 equal to 23y. You can see that on the left hand side 63x means the number of bananas in each heap. There are totally 63 heaps. So for each heap we don't know how many bananas, so 63 times of x plus there are 7 single fruits available, so we are adding 63 times of x plus 7, we will get total number of bananas. There are totally 23 travelers. They will get each they will get the number of fruits equally. So the corresponding mathematical equation is 63x plus 7 equal to 23y. Here we are only focusing the integer solutions. In number theory, the integer solutions play a vital role. Not only in number theory, in real life, we are using the integer solutions. The Diophantine equation. It is an equation with integral coefficients in which only integral solutions are sought. Uh, there are some of the equations. You can see that 2x plus 3y equal to 4 and x square plus y square equal to 1, x square plus y square equal to z square. The last two equations are non-linear and the first equation is linear. These are all the Diophantine equations because we are focusing only on the integer solutions. These are the Diophantine equations in two variables. Now the linear Diophantine equation. A linear Diophantine equation in two variables x and y is a Diophantine equation of the form ax plus by equal to c, where a, b, c are integers. Naturally, we have a question whether every linear Diophantine equation has a solution. So for answering these questions, also if the solution exists, under what condition a linear Diophantine equation have a solution. And similarly, if the linear Diophantine equation is solvable, how many solutions for the given equation, whether it is a finite number of solutions or an infinite number of solutions. Think about these equations. The first equation is 4x plus 6y equal to 7, and the second equation similarly 2x plus 4y equal to 8, and the third equation 3x minus 4y equal to 10. You can see that the first equation on the left hand side, it has we will get an even integer, whereas the right hand side is an odd integer. So we cannot equate these two equations because we are searching for integer values. So this equation has no solution. But what is the condition for obtaining a solution of linear Diophantine equation? For that, we have to go through some theory. The necessary and sufficient condition for the existence of the solution of linear Diophantine equation is given here. So the linear Diophantine equation is solvable if and only if D divides C, where D is nothing but the GCD of A and B. If one particular solution is found, then we can find the infinite number of solutions for the given linear Diophantine equation. Suppose x naught y naught be the uh, particular solution of a linear Diophantine equation, then all other solutions are given by the following formula: x equal to x naught plus b by d into t, y equal to y naught minus a by d into t. Here x naught, a, b, d are known integers, and t is an arbitrary integers. That is, you can give any integer to t. So now come to the solution part of Mahavira's puzzle. The mathematical equation for that puzzle is 63x plus 7 equal to 23y. Rearranging the equation, we get a linear Diophantine equation. So, for calculating the solution of the linear Diophantine equation, uh, 63x minus 23y equal to minus 7. For that, for the equation, we must calculate the GCD for 63 and 23. The GCD value is 1, so 1 divides the right hand side minus 7. Naturally, this equation has a solution. So once we get a particular solution of this equation, we can easily find out the infinitely many solutions. So our next aim is to find a particular solution for the linear Diophantine equation. So first we calculate GCD for 63 and 23 through Euclidean algorithm. So you can see that 63 is divided by 23 and the remainder is 17, and repeatedly Euclidean algorithm is applied, we will reach the last equation. From this set of equation, we substitute backward, we move from backward from the last equation to first equation. We get backward substitution in Euclidean algorithm. That is, from the last equation we have 1 equal to 6 minus 1 time 5, and similarly apply the uh, backward substitution in Euclidean algorithm repeatedly. We get the last equation 1 equal to 11 times 23 minus 4 times 63. Actually, the linear Diophantine equation of our puzzle is 63x minus 23y equal to minus 7. So rearranging the equation, we get 63 times of 4 minus 23 times of 11 equal to minus 1. Multiplying 7 on both sides, we get the second equation. From 1 and 2, we can find a particular solution of the linear Diophantine equation, that is, comparing these two equations, x equal to 28 and y equal to 77. Once we get the particular solution, we can able to find out the infinite collection of solutions. So it is calculated using the theoretical formula: x equal to x naught is 28 and b is minus 23. The GCD value is 1, so minus 23 times of t. And similarly, y equal to 77. Y naught here, y naught is 77 minus 63 times of t. So where t is any integer, so if we put t equal to 0, we have x naught equal to x equal to 28 and y equal to 77, which means that what is our x? X is number of bananas in each heap. If we have 28 bananas in each heap, then each traveler will get 77 fruits. Similarly, if we change the number of bananas in each heap, the corresponding solution of y also change. So we can visualize the infinite collection of solution. The changing by changing the values for t, that is integer, by assigning the integer values, we get a different set of solutions. Thank you for your patient listening. Thank you, one and all.